if g of x is equal to 3 minus x squared times e to the x, and we're asked to find the derivative, well, we need to recognize that this is a product, so we're going to have to use the product rule, which means the derivative is going to be 1d2 plus 2d1. That means the first factor, 3 minus x squared, d2 is the derivative of the second factor, the e to the x. And derivative of e to the x is e to the x. So that's 1d2 plus 2d1. The second function, e to the x, times the derivative of 3 minus x squared, which is negative 2x. We can kind of clean this up a little bit. Both terms, the first term and the second term, have a factor of e to the x, so I'll factor that out. And I'll be left with 3 minus 2x and minus x squared, if I were to just put it in order. I like to have it in even better order, so I'd like to factor out a negative 1 out of there as well. Then I'll have x squared plus 2x minus 3. And that's pretty nice. That's going to be real helpful because in the second part, we're asked to find all the values of x for which the derivative is equal to 0. Right now, I have the derivative being negative 1 e to the x times x squared plus 2x minus 3. And I can factor that even more into x and x, and 1 and 3. I'll need a positive 3 and a minus 1 to make that 2 in the middle, equal to 0. Since I'm multiplying a bunch of stuff together to equal 0, that zero product property says that one of these factors has to equal 0. Well, e to the x is never going to equal 0. E to the x is always positive. Negative 1 times e to the x is always going to be negative, so this will never happen. In the second factor, though, if x minus 1 equals 0, then x is equal to 1. And in the last factor, if x plus 3 is equal to 0, then x is equal to negative 3. In part C, it asks us to make a sign chart for the derivative. So we're going to need to remember what the derivative of g of x was. So g prime of x we just found as being negative 1 e to the x times x minus 1 and x plus 3. If we're going to create a sign chart, we need to test each interval. So first I'm going to pick a point way down below negative 3, like negative a billion. In that case, negative 1, well, negative 1 is always going to be negative. E to the negative a billion is a very small number, but it's still positive. It'll always be positive. Negative a billion minus 1 is negative a billion and 1. And negative a billion plus 3, don't really care how you call that number, but I do know that it will be negative. So overall, I'm going to take a negative times a positive times a negative times a negative. So that entire product will be negative. Now I'm going to go through again and pick a number inside of here, like 0. If x is equal to 0, negative 1 is still negative. E to the 0 is 1, a positive 1. 0 minus 1, still negative. But 0 plus 3 is now positive. Now our entire product has changed from being a negative number to being a positive number. And finally, I pick a number that's bigger than 1, like a billion. If x is equal to a billion, negative 1 is still negative. E to the billionth is a very large number, but a positive number. And a billion minus 1 is now positive, and a billion plus 3 is still positive. Since I'm taking a negative times a positive times a positive times a positive, this entire product is going to be negative. Now, as we take a look at our sign chart, we can kind of get a feel for what the graph of g of x, that original function, is going to look like. Since this is a sign chart for the derivative, on this first interval, the derivative is negative, which means the original function is decreasing. It's going down. On the middle interval, the derivative is positive, so the function is increasing. And then after 1, the derivative turns negative again, and it's going down. At both negative 3 and positive 1, the derivative is 0, which means we'll have maximums and minimums at those 2 points. once we have a graph of this, it's kind of obvious that at 1, that's where we'll get a max. And at -3, that's where we'll get a minimum. So now you're asked to describe in part D and E those maximum and minimum values, where they occur, and why they happen. In order to find the maximum and minimum values, we need to determine what g of 1 and g of -3 are. The maximum value, we said, happens when x is equal to 1. So that means I'm going to have to take 1 and plug it into the original function, g of x. So that would be 3 minus 1 squared times e to the first power, which is just 2e. So the maximum value is going to be 2e. It's going to occur when x is equal to 1 because the derivative, f prime, changes from positive to negative. The minimum value is going to happen at x equals -3 because the derivative changes from negative to positive. So the original function changes from decreasing to increasing. But what is that minimum value? That's going to be the value of the function at -3. So we're going to take that and plug it in. 3 minus 3 squared times e to the third. Well, 3 minus 9 is -6, and e to the third is e to the third. So that's our minimum value, -6 e to the third. It happens at -3 because the derivative changes from negative to positive.